Today we're going to talk about chemical bonds, what actually happens and how chemicals form. So if you remember from our previous discussion, we talked about Dalton's atomic theory. One of the postulates of Dalton's atomic theory was that elements combine in simple whole number ratios to form compounds. So elements combine to form compounds, but why do they do that? Why do elements actually combine together? Why don't they just stay elements? So to talk about that, we have to remember something about the elements. So there's that one group of elements that don't actually react. They don't combine with things. The noble gases. The noble gases do not readily react with other elements. And the reason they don't do that is because they are already chemically stable. So what do noble gases have that other elements don't? Remember, the reason why we call them noble gases is because they don't interact with other elements. Just like noble people did not interact with common people, the noble gases don't interact with the common elements. Well, what did noble people have that common people didn't? They had financial stability. So noble gases have chemical stability, and other elements in their elemental form do not have chemical stability. Well, what makes them stable? An element is stable when it has 8 valence electrons. And if you remember, the valence electrons are the s and the p orbital electrons. Well, the noble gases are the last element in a given row, and so therefore they have a full s and a full p in their outer energy level. So they have 8 valence electrons. So why do elements form compounds? It's because all of these common elements, just like all people, are trying to look like the noble people. We want to be rich. We want to have the money. We want to have the financial stability. We want to be like the noble people. We want to be like them. So we do what we can. We dress, we drive cars, we try and get money. We try and make ourselves look like we're one of the noble people. Why do elements? They want to look like a noble gas. Noble gases are electrically stable or chemically stable. So other elements want to be chemically stable as well by looking like a noble gas. So they have to get a stable valence of 8. All right, the noble gases have 8 valence electrons. Everybody else wants 8 valence electrons. So they're going to do things to get 8 valence electrons. That's called the octet rule. Oct meaning 8. All right, the elements will gain, lose, or share electrons in an attempt to gain a stable octet, a stable valence of 8 valence electrons. That's called a stable octet. So if you have 8 valence electrons, you have a stable octet. That's the reason why elements form compounds. They are trying to get a stable octet. So there are basically 2 ways that atoms can do this. As you saw from the definition of the octet rule, they gain, lose, or share electrons. So they can either transfer electrons from one atom to another. So one atom will gain electrons, one atom will lose electrons. They're transferring electrons. Or they will share electrons between each other. Those are the 2 basic ways that chemical bonds will form. 2 ways that you can get an atom stable by taking away electrons, adding electrons to it, or just sharing electrons between them. Those are their methods for becoming chemically stable. So when atom transfers electrons, they become charged. If it gains electrons, then it's going to have more negative electrons than it has positive protons. So if it gains electrons, it's going to become negative. If it loses electrons, it is going to now have less electrons than it does protons, so it will become positively charged. All right, an ion, as we talked previously, is an atom or a bonded group of atoms that has a positive or negative charge. When it gains or loses electrons, it becomes an ion. If atoms lose the electrons, it becomes positively charged. I just said that. If it loses electrons, it becomes positively charged because it's now going to have fewer electrons than protons. Remember, the number of protons don't change. The electrons move. So if it loses electrons, it's positively charged. We call that a cation. We've gone over this in a previous video. I'm reiterating it now. A cation is a positive ion. If it gains electrons, it's now becoming more electrons than protons, so it's going to have a greater negative charge than a positive charge, so the overall ion is going to be negatively charged. If it gains electrons, it becomes negatively charged, and we call that an anion. So cations are positive, anions are negative. Now, elements with high electronegativity, the ones over on the right side of the periodic table, tend to gain electrons. Because remember, electronegativity is how much it wants to hold on to those electrons. So if it has a high electronegativity, it's going to tend to gain electrons. It's going to pull electrons in, and they're going to become anions. Elements with a lower electronegativity are going to be more willing to give up their electrons and become cations. So if you look at the periodic table, you will notice that lower electronegativities are on the left side of the periodic table, and the higher electronegativities are on the right side of the periodic table. Electronegativity increases from left to right across the periodic table. So metals, which are all on the left, form cations, and nonmetals, which are all on the right, tend to form anions. Now, I said tend to form because some nonmetals will form cations sometimes and anions other times. But for the most part, nonmetals are going to form anions. Metals only form cations. Metals are only going to become positively charged. That's one of the things that makes them metal. So let's see an example situation so I can kind of explain through the nature of this bonding and how the transfer of electrons actually works. So meet Tana. Tana has an extra bag of electrons here, and it's making her a little unbalanced. She's not stable right now. She really doesn't like those. So in comes Stephen. Stephen also is unbalanced. He has an extra bag of electrons. But here's the deal. Tana wants to get rid of her electrons. So she gets rid of them, and now she's stable. Stephen, now he's balanced out. He's happy. And Tana is so overwhelmed with attractedness to Stephen for taking her bag that they are now bonded together in their mutual attraction. So as you saw, and as we talked, metals become positive because metals give up their electron. And nonmetals become negative because they're going to take in an electron. And then that positive and negative attraction, positive charges and negative charges are attracted to each other. That's what we call an electrostatic attraction. That electrostatic attraction brings them together, and that's what actually forms the chemical bond. It creates a bond between the atoms. The positive and negative are attracted. They're now stuck together with the electrostatic charge, and they are bonded together. We call that an ionic bond because it's a bond formed between two ions. A positive ion and a negative ion form a bond, and that is an ionic bond. All right. When elements form ionic bonds, their goal is to get a stable octet. So they're going to gain or lose a certain number of electrons based on their normal valence number. So if you remember the valence numbers of the groups, we talked about in the previous unit about the periodic table, the valence numbers, the group that it's in can tell you the valence. So if you remember, group 1 had 1 valence electron, group 2 had 2 valence electrons. These, we gave you numbers previously. That wasn't exactly right, and I told you that then, but they actually have multiple valences, and we'll talk about why a little bit later in a later video. But group 13 has 3, 14 has 4, 5, 6, 7, and 8. So group 18 has 8 valence electrons. They're already electrically or chemically stable. So they have their 8 valence electrons. Everybody else has less than 8. Okay. So what's going to happen is as an element gains or loses electrons is going to depend on how close its valence is to 8 already. Ones that are really close to 8 are going to gain electrons because that's easier to do. Ones that are farther away from 8 are going to lose those electrons. And we'll see why that means right now. So for example, let's say we have calcium here. Calcium has 2 valence electrons. Now, it has 2 options. It wants to get 8, so it has 2 options. It can either gain 6 more electrons to look like krypton, because remember, the goal is to look like a noble gas. So if it gains 6 electrons, calcium will look like krypton. Or it could lose its 2 valence electrons. And if it loses its 2 valence electrons, it's going to look like argon. Either way, it's looking like a noble gas. The goal is to look like a noble gas. So if it loses those 2, it will look like argon. If it gains 6 more, it'll look like krypton. Well, it's a whole lot easier to lose 2 than it is to gain 6. So that's what calcium is going to do. It's going to lose 2 electrons and become positively charged. Now it's going to have a charge of positive 2 because it lost 2 electrons. So right here before you have potassium. Potassium has 1, so it's going to lose its 1 electron and look like argon. And so if it loses 1, it's going to be positively charged with a positive charge of 1. And if you go all the way across here, so we've got gallium has a valence of +3. So it's going to want to lose those 3 electrons in order to look like argon, and it's going to have a charge of +3. This column right here is where it gets a little wonky, all right? Because like silicon has the option of either gaining 4 and looking like argon or losing 4 and looking like neon. And it could do either or. So sometimes silicon will have a +4 charge. Sometimes it will have a -4 charge. And so sometimes it loses, sometimes it gains it. Carbon also. So this column is kind of a plus or -4. That's not an exact complete rules. This is just the generalization. Some of these atoms are only positive. For example, lead is a metal. Metals are only positive. But the non-metal ones here, they can be positive or negative depending on certain situations. Okay. And then you go on to, say, this group, we have phosphorus. There's 5 valence electrons. So it can either lose those 5 and look like neon or gain 3 more and look like argon. Well, it's going to want to gain 3 more and look like argon. So phosphorus is going to have a -3 charge because it's going to gain 3 more electrons. Oxygen's group here is going to gain 2 electrons to look like the noble gas there. And so it's going to have a -2 charge. So that's how the charge works based off the valence. So you remember the valence numbers. And so now if we look at the whether or not it gains or loses electrons, it's going to be charged. And the charge numbers are going to look like this. You're going to have group 1 is going to be +1. Group 2 is +2. These have variable charges because they have variable valences. We'll talk more about that a little bit later. But then you have a +3 and then plus or -4, -3, -2, -1. And of course, their charge is 0. Their oxidation number, as we call it, is 0 because they gain and lose 0 electrons. They're already stable. Okay. Now, the ratio of positive to negative ions in an ionic bond depends on these charges. So remember, we said that elements combine in whole number ratios. Now, that ratio of positive to negative is what determines that ratio. All right, the whole goal is, 1, they all want to be chemically stable and have 8 valence electrons, but they also, the compound, the thing that's formed has to be electrically neutral. So if I have an element that is a +2 and an element that is a -3, +2 and -3 makes a net charge of -1. So that does not actually cancel out completely. So we can't have just one of each. All right, we can't have just 1 +2 and 1 -3 because they don't cancel out to be neutral. So we have to have a proper ratio. So we're going to get the proper ratio here by looking at the charges. So we have something here with a +2 charge. Notice it has 2 valence electrons, so it's going to lose those 2 electrons to become +2. And we have something with a -3. It has 5 valence electrons, and it's going to gain 3 in order to become a -3. So in order to be stable, this one has to have a charge of -3. In order to be stable, this one has to have a charge of +2. So what's going to happen is, first off, we're going to have our beryllium here is going to give up an electron. It's going to come over here to the phosphorus. And so now I have a -1 and a +1. Neither one of them are happy. Neither one of them are stable yet. So beryllium's going to give up its other electron. Now beryllium is happy. It's got its +2 that it wants. It's stable. It's given up those electrons. It now looks like a noble gas. It's happy. It's stable. But phosphorus is not. It has a charge of -2. It only has 7 valence electrons. So in order to help this out, we're going to need more beryllium. So we're going to have to add ourselves another beryllium atom here. Well, this beryllium is going to give up its electron. But now we are back to the problem of we don't have enough atoms because my phosphorus is now happy. It's stable. It's got its 3 extra electrons. But this beryllium still has 1 electron that it wants to get rid of, but nowhere for it to go. So we're going to need another phosphorus. So we have this other phosphorus that we bring in here. And so the beryllium donates and it's happy. Okay, so this beryllium is happy, this beryllium is happy, this phosphorus is happy, this phosphorus is not happy. So we're going to have to continue to add. Phosphorus needs more electrons, so we're going to add ourselves another beryllium atom. And that other beryllium atom here is going to give up an electron to phosphorus. And now we got a -2. That's not quite happy. And so we give up another one. So now phosphorus has 8 valence electrons. This phosphorus is happy. Has 8 valence electrons. This phosphorus is happy. All of these have given up their extra electrons. They're all happy. And so we are all happy. Now if you look at the charges, you'll notice it's 2, 2, 2. That's a total of +6. And -3, -3. That's -6. So -6 and +6 combine together to give you a neutral atom. So what's actually going to happen is these are going to form some kind of a crystalline structure where they alternate and are going to share and be mutually attracted and all of that to each other. So this is what we mean by the ratio has to do with it. Now you'll notice that this was a -3 and this was a +2, and it took 3 of these to make 2 of those. So look at common multiples as a way to think about these ratios. So this is how you deal with it if they're not equal charged, if they have different charges like a 1 or a 2.
So ionic bonds form when electrons are transferred between atoms. The other way that elements can get a stable valence of 8 is by sharing electrons. That's their other way. So they transfer it and form ions, or they can share those electrons. And when they share those electrons, they get their stable 8 a different way than transferring. So let's see an example situation of how that would work out.
Say hello to Thomas and Stephen. Both of them have their electrons and they are a little unbalanced. Well, they both want to be balanced, but neither one of them wants to give up the electrons they have. So they make the lovely decision to share their electrons together. So now they both have the electrons that they want, but they're balanced and they're happy, but they're stuck together because as long as they're sharing those electrons, they are bound together. There we go.
So that sharing of electrons to gain a stable octet forms a bond between those atoms. As long as they're sharing those electrons, they're stuck together, right? That is what we call a covalent bond. The word covalent actually means the prefix co means together. So that's why we cooperate, we operate together. A coworker is someone you work with. So co means with or together. So a covalent bond is a bond where the valences are together. They share the valent electrons. So a covalent bond is a bond where they're sharing the electrons, all right? And they always form between non-metals. So you'll notice that we talked about ionic bonds were a positive ion and a negative ion, something with low electronegativity and something with high electronegativity, and the electrons are transferred, and electrostatic, they bond together. With a covalent bond, however, we're dealing with two things that both want electrons. They don't want to give up their electrons at all, but they do want to be stable. So instead of giving up their electrons to become stable and just taking electrons to become stable, when they work together and they share those electrons, it always happens between two non-metals like phosphorus and sulfur. Two non-metals will bond together in a covalent bond. Now, due to the differences in their electronegativities, elements do not share electrons equally, okay? Fluorine is a very electronegative element. Oxygen is the next highest electronegativity. Carbon, not as electronegative. So when they bond together, if carbon and oxygen bond together to form, say, carbon monoxide, one carbon atom and one oxygen atom, oxygen actually wants those electrons more. It's got a higher electronegativity, so it's going to pull the electrons towards it a little bit more. So it's not going to share them equally. They're kind of sharing unequally. Oxygen's going to get the electrons most of the time. So the more electronegative element is going to have the electrons more of the time as they're flying around and being shared between the two nuclei of the two atoms. The higher electronegativity and electronegative atom is going to get the electrons a little bit more. That's going to create a bond where one end is slightly more negative than the other end, because the electrons are over here with the oxygen a little bit more than they're over here with the carbon. So when the electrons are over here, this side of the compound is negatively charged, and when they're not over here, this side is positively charged. So you have a part of your molecule that's slightly negative and part of your molecule that's slightly positive, which creates poles, a positive pole and a negative pole. And so we call that a polar bond. It's a bond that the sharing is not done equally. Okay. Almost all covalent bonds are slightly polar. Some are very polar, some are just a little polar. It depends on the difference in those electronegativities. An electronegativity of 4 being combined with something of electronegativity of 2, you're going to have a very polar bond. But if you have something whose electronegativity is 4 and it's being combined with something, someone's electronegativity that's 3.7, that's going to be a slightly polar bond. The only purely covalent bond, which means complete equal sharing of the electrons, is going to come between atoms of the same element. So if you have an oxygen atom combining with another oxygen atom, they're both oxygen, they have the same electronegativity, they want those electrons exactly the same amount, so when they share those electrons, they're going to share them equally. That is a purely covalent bond. The only purely covalent bond happens whenever electrons are shared between atoms of the same element. All right. Now, when atoms of the same element bond together, they form what is known as a diatomic molecule. Di meaning 2, atomic atom. So a diatomic molecule is a molecule made of 2 atoms of the same element. Now, there are 7 elements that always form diatomic molecules when they are in their elemental form. So if we find them out in nature as elements, not reacted with something else, so they're in their elemental form, they are always going to exist as diatomic because they're very, very highly reactive. So if they don't react with another element, they're going to react with themselves and they're going to combine with themselves and form diatomic molecules. Those 7 elements are bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine. Now, the order that I gave those to you is because of the way that I was taught this, and it helps with a little acronym to remember the order of, or it's not really the order, but to help you remember the 7 of them is this lovely little word that I say, Brinkelhoff. All right. It's just kind of a fun word to say, Brinkelhoff. Bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine. Now, if that doesn't help you remember it, Brinkelhoff doesn't help you remember which 7. If you look at the periodic table and you notice that you've got nitrogen, oxygen, fluorine, chlorine, bromine, and iodine form kind of a 7 over here on the periodic table. And then, of course, you have hydrogen up on this side. But you've got a 7 plus hydrogen, and there are 7 of them. So that's another helpful way to remember which 7 there are. Just don't forget hydrogen. So Brinkelhoff, those 7 elements, they're always going to be diatomic. All right, so let's do a little bit of a recap of our lesson so far. Elements want to have a stable octet of valence electrons. They're going to do that by donating or accepting. Metals are going to donate or give up their valence electrons and become positive. Metals, non-metals are going to accept or receive electrons to become negative ions, otherwise known as anions. The cations and the anions bond together to form an ionic bond. Ionic bonds form when electrons are transferred from one atom to another. Nonmetals can also share their electrons with other nonmetals and form covalent bonds. Most covalent bonds are polar because electrons are not shared equally. Pure covalent bonds occur between atoms of the same element. That is our basic understanding of bonding and how chemical bonds form, why chemical bonds form. What you need to remember the most is that chemical bonds form because elements are trying to look like a noble gas. They're trying to get a stable octet of 8 valence electrons. All of this happens. So all of chemistry happens because that's what they're trying to do. Now, there are ways that they can become more stable than they are, and we'll get into all that as we move forward. So in the next video, we're going to talk about the characteristics of the compounds that are formed from these different types of bonds. So hopefully you stick around for that. Thanks for watching and have a day.